division. We'll do some examples with synthetic division. So we're not going to do this whole lesson, but we will go through some examples. So let's go down here to class example 2. So use synthetic division to find the quotient and remainder when 5x to the 5 minus 6x4 plus 3x squared minus 2x plus 1 is divided by x plus 2. So whenever we're doing synthetic division, we always, we put the 0 of the divisor here. So the divisor was x plus 2. The 0 of x plus 2 is negative 2. And we put the coefficients from highest degree term to lowest degree term here. It's very important if a term is missing. So if you say you don't have, oh, like here, sorry, I already missed one. So notice how there's no x cubed term here. So this is x to the 5, x to the 4. There's no x cubed term, so we have to put a 0 in there. Then we put in our 3 for x squared, our minus 2 for x, and our 1 for our constant. We always start synthetic division just by bringing down that first coefficient. And now we multiply negative 2 times 5 is negative 10. The difference with synthetic division is instead of subtracting at each step, you add at each step. So this is negative 16. Negative 2 times negative 16 is 32. 0 plus 32 is 32. Negative 2 times 32 is negative 64. Adding 3 plus negative 64 is negative 61. Negative 2 times negative 61 is 122. When we add, that gives us 120. Negative 2 times 120 is negative 240. Adding gives us negative 239. Now, that last number is always our remainder. And then we go up, starting with degree 0 on x, to degree 1 on x, degree 2 on x, degree 3 on x, degree 4 on x. If we started with x to the 5, our answer is always going to start 1 degree less, so x to the 4. So the quotient here, this division really equals 5x to the 4 minus 16x cubed plus 32x squared minus 61x, sorry, I'm out of room, plus 120, with a remainder of negative 239. Okay, we're going to skip B and C because we're going to look at that in the next lesson. Example 3, if x plus 3 is the divisor of the following synthetic division, calculate the values of m and p. Okay, so we know this is the divisor, so this goes here. We then bring down the 2. Done that. So negative 3 times 2 is negative 6. We add, that gives us negative 4. Negative 3 times negative 4 is 12. That goes here. That gives me a piece of information. I now know that this, negative m plus 12, must be 2m. And I'm going to solve for m at this step. So I can add m to both sides, divide by 3 to give me m equals 4. Well, if m equals 4, 2 times m is really 8. So now I can continue going here. Negative 3 times 2m, so negative 3 times 8, this should be negative 24. And now we add. 16 plus negative 24 is negative 8. So we have m is 4, p is negative 8. A bit of a strange question. I really don't think you'd see one on the test. Okay, so we're going to do a division here. Again, questions worded slightly differently. So 2x cubed minus 4x squared plus 8x plus 3 is divided by x plus 2. The remainder is 3. Determine the value of a. We're going to leave this question because this is much easier to do with the remainder theorem. So I'll show you how to do it with that in the next lesson. So it gets a little bit trickier when we're dividing as a value in front of the x. The key is to remember we always use the 0 of the divisor. So if we're dividing by 3x plus 2, we first need to find the 0 of that, which is negative 2/3. So we can put negative 2/3 here, and then we put our coefficients in decreasing order. I don't need to add any zeros this time. And then I step through the process. So I bring down the 6. Negative 2/3 times 6 is negative 4. Adding gives us negative 12. Negative 2/3 times negative 12 is 8. Adding gives us negative 3. Negative 2/3 times 3 is negative 2. Adding gives us a remainder of 3. So this is equal to 6x squared minus 12x minus 3, remainder 3.